Good morning. Welcome back to lecture series on storage area networks. So in the previous lecture, we had discussed about the fiber channel internet protocol, right? And we had seen fiber channel internet protocol topologies. So in this lecture, we shall now be discussing about the fiber channel over Ethernet. So upon the completion of this lesson, we will be able to understand what are the benefits of Fceo, right? And then we shall also be in a state to describe the working of Fceo, followed by we also have a brief knowledge about what are the various physical and logical elements that make up a fiber channel over Ethernet standard, and then we shall also be in a state to differentiate between various different protocol stacks that we have studied so far. Okay, so let us start our discussion with Fceo. So then a fiber channel over Ethernet, that is Fceo, is a new protocol that tries to map the fiber channel protocol natively over Ethernet. Right, so Fceo is a proposed standard for using the fiber channel protocol over Ethernet networks. So Fceo enables the SAN traffic to be natively transported over the Ethernet networks, but by the same time protecting and extending the investments that the enterprises have to make in storage networks, right? So Fceo basically would enable the organizations to continue to run the fiber channel over the same wires as their data networks, right? So in order to understand it much better, let us take a scenario of a data center, right? So data centers typically have multiple networks, right? So they have multiple networks to handle various different types of input-output traffic. So for example, an Ethernet network, right? An Ethernet network in order to perform a TCP/IP communication, and an FC network can be used for performing the fiber channel communication, right? So as we already have an idea that TCP/IP is basically used for client-server communication. It can also be used for the data backup as well as to perform communications related to infrastructure management, right? So fiber channels, as we know that fiber channels are typically used for moving block level data between the storage and the servers, correct? So in order to support this multiple networks, the servers in the data centers are needed to be equipped with multiple redundant physical network interfaces, right? For example, they may need multiple Ethernet and fiber channel cards as well as adapters, right? In addition to enable the communication, different types of networking switches and physical cabling infrastructures are also needed, right? So therefore there is a need for different kinds of physical network infrastructure to be set up, and which leads to overall increase in the cost as well as the complexity of the data center operations, right? So therefore fiber channel over Ethernet protocol tries to offer consolidation of both different types of networks, that is the LAN as well as the SAN traffic over a single physical interface infrastructure, right? So unlike other storage networking protocols that use Ethernet, this emerging Fceo standard can utilize a new version of Ethernet standard that makes it more reliable, right? So then this Fceo basically helps the organizations to deal with challenges of having multiple different network infrastructures, right? So the major key benefit that this Fceo offers is the IO consolidation. So let us see what exactly do we mean by the I/O consolidation. So before moving on to looking at what exactly is I/O consolidation, we first have a look at the infrastructure required, right? Infrastructure required before the deployment of Fceo, right? By now we have understood that the when you make use of Fceo, you include a lower capital and operating costs, right? Because there is a dramatical reduction in the number of adapters, switch ports, and cables that are required here, right? And similarly, there is a lowering cooling requirements and power saving, right? So this results in a lower total cost of ownership, and the Fceo enables input as well as output consolidation by allowing LAN and SAN traffic to converge into a single cable or a link, right? So it reduces the number of server cables, right? Along with it, it also reduces the number of adapters and the switch ports that can be used in the data centers, right? So this reduction can help us greatly simplify the physical infrastructure, right? So it also reduces the administrative overhead and the complexity associated with the management of the data center here, right? So as we are aware that the storage resources are accessed by making use of HBAs, and the IP network resources are accessed by making use of NIC cards by these servers, right? And if we had a situation wherein the data centers have had hundreds of thousands of servers, then it would have needed us to make use of a large number of adapters, cables, and switches, right? Which could simply yield into a very complex environment, which could be very difficult to manage as well as scale, right? So using Fceo, all these challenges have been addressed and reduced to a greater extent by reducing the cost of power, cooling, floor space, etc., right? So all these all these challenges can be overcome with the help of Fceo implementation there. Okay, so then let us see the situations. Okay, so we said Fceo basically helps us to allow or enable both the LAN as well as SAN traffic to converge onto a single cable or a link, right? So this particular diagram helps us understand the difference here. So in the first part here, you can see a typical server connected in the data center environment. So if you want to transfer a data over SAN, then you need to have a fiber channel protocol, right? So if you want to transfer the data over a SAN, then you need a set of redundant fiber channel host bus adapters. So similarly, if you want to transmit the data over LAN, then you need multiple NIC cards here. But when it comes to the server with Fceo implementation in it, then you can see that both LAN and SAN are going to make use of a single converged network adapter. So converged network adapter is nothing but CNA, that you can see it here, right? So in the second diagram, I'm talking about CNA. So this CNA, that is converged network adapter, allows us to send both LAN as well as SAN traffic on a single cable or a link here. So this is what we mean by I/O consolidation, right? So this reduces the requirements of multiple network adapters at the server to connect to different networks, right? And therefore overall it reduces the requirements of adapters, cables, and switches, and along with that it also reduces the cost and the management overhead here, right? So now we move on to the infrastructure without Fceo, right? We have seen I/O consolidation, and we now explore a situation of a data center without Fceo implementation in it. So this particular diagram shows a topology of the current infrastructure wherein LAN and SAN are two different networks, and the storage resources are accessible by making use of host bus adapters. So you can see the FC switches lying there, and then we have network resources that are accessible by the NIC cards by the hosts. So therefore you can see IP edge switches here. So by this diagram you can happen to notice that there are multiple FC switches and multiple IP edge switches, right? And by the same time there are huge number of connections that exist between the host and the storage arrays, right? So now moving on to the next diagram. So here we can see the infrastructure which makes use of Fceo, right? So it shows an I/O consolidation with Fceo using Fceo switches and CNAs. So the middle layer that you can see is the Fceo switch here. So this Fceo switch passes the fiber channel traffic to the SAN, and by the same time the Ethernet traffic is sent to an attached Ethernet network, right? So with Fceo, the cable requirements from the host to the Fceo switches are reduced to a maximum extent here, right? So which in turn reduces the cooling costs, the management requirements, and the overall operation costs here, right? So I guess you are able to make out a difference here. There are very less number of connections existing between the Fceo switches and the hosts here, right? So then moving on to various different components, the physical elements that make up an Fceo, right? So basically there are three components that make up the physical element, physical elements that make up an Fceo. The first one is the converged network adapter, and the second one is the cables, and the third one that has not been mentioned here is the Fceo switch, right? So the CNA, that is the converged network adapter, consolidates the data networking of an NIC card with the storage networking of the fiber channel HBA onto a single adapter, right? So therefore it eliminates the need of having a separate interface card for fiber channel and IP network, and it consolidates the IO operations onto a single 10 gigabit Ethernet link, right? So the internals of the first generation CNAs include a separate 10 gigabit Ethernet and fiber channel and Menlo ASCII. You can see the diagram of CNA on the top here, right? So this Menlo ASCII, that is application specific interface communication, is used to encapsulate the fiber channel frames into Ethernet frames, right? And there are two different types of cables that can be used here as connectivity options. One is known as the copper based Twinax, and the other one is the standard fiber optical cable, right? So copper based Twinax cables are the cost effective options. A Twinax cable basically is composed of two pairs of coppers that are converged within a shielded casing, right? And the each end of the Twinax is terminated by SFP and GBIC, right? So here the CNA basically provides the functionality of both the NIC and the fiber channel host bus adapters in a single adapter, right? So it consolidates both the types of traffics, therefore eliminating the need to deploy separate adapters, right, and cables for fiber channel as well as Ethernet communication, right. So as this happens, thereby it reduces the number of server slots and the switch ports that are required, right. So when this thing happens, the converged network adapter offloads the Fceo protocol processing task from the server, right. So the server now becomes free and it makes use of its CPU resource for processing the applications here, right. So then, as we have seen, it's very important that there are only two options that are available for Fceo cabling. One is the copper based twin X and the other one is the standard fiber optic cables, right. So and the third one, that is the Fceo switch that we have seen, has both Ethernet switch as well as the fiber channel switch functionalities in it, right. So Fceo switch has a fiber channel forwarder in it. It also has a Ethernet bridge and a set of Ethernet ports as well as some optional fiber channel ports in it, right. So the function of this fiber channel forwarder is to encapsulate the fiber channel frames that are being received from the fiber channel ports into an Fceo frame, right. And it's also responsible for de-encapsulating the Fceo frame that is being received from the Ethernet bridge back into an Fc frame, right. So we have seen, so in today's lecture we have seen what is Fceo, right, what led to the need of evolution of Fceo, and then we happen to see three basic elements that make up an Fceo. So in the next lecture we shall discover what do we mean by Fceo frame structure.